The next part of trigonometric functions of any angles deal with evaluating trig functions using reference angles. So we begin by drawing an angle theta. And if we have some circle, like this, and then we have a point P that's on the circle, and our angle theta is right there. And the point P is on a circle and the radius of that circle is R. Then the reference angle is the shortest distance to the horizontal axis. You might recall that. And so right here, this is our reference angle, or theta prime. So by definition, what we have for the value of sine of theta, right here on this triangle, we would go ahead and extend it. We would have our x value, our y value. So this is p of x, y. And by definition, we know that sine is y over r. And we would know that cosine of theta is x over r. At this point, we're going to ignore the negatives, even though we know in this quadrant x is, would give us some sort of negative value. But instead, we're using reference angles to evaluate what's positive and what's negative. So if we redraw our circle like this, and this was our point P, and that was x, y. That circle had a radius of r, and our angle was theta. If we drew the reference angle in standard position, so this angle up here, it would look like this. Okay, that would be theta prime. Theta prime is right there. Now both of these form triangles. This is another point. We'll call this P prime. And we'll just say this is x prime and y prime. Okay, so x was the value here, y is the value here. X prime, y prime. In this case, we have that sine of theta prime is y prime over r, because this is also a length of r, it's the same circle. And cosine of theta prime is x prime over r. Now notice that these 2 points, P and P prime, line up in terms of their y values. So y and y prime should be equal because they line up right here. And so since we have that y equals y prime, and for our values for sine, then we get that sine of theta equals sine of theta prime. And in a similar fashion, we have that x and x prime are actually going to be opposites. So we have that x equals negative x prime. One is going in the positive direction, one's negative. And so we get that cosine of theta equals negative of cosine of theta prime. So you may have noticed that these are two similar triangles, with the only difference being the x-coordinate having opposite signs. Therefore, the values of each trig function that we're going to get from these two triangles will be exactly the same, except possibly the signs, especially the ones that involve x's and x primes. And so since the only difference is the signs, then we can determine the sign by looking at what we did in the previous video. Which quadrants are positive and negative in which quadrants, or which functions rather, are positive or negative in each quadrant. Now, the values of a trig function for a given angle are the same as the values of the same trig function, but for the reference angle, except possibly a difference in the sign. One might be positive and the other is negative. Now, to calculate the value of a trig function at any given angle, we're going to do the following steps. Step 1, draw the angle in standard form. Step 2, determine the reference angle associated with that given angle. And if you need a refresher on reference angles, see our section in unit circles. Step 3, evaluate the trigonometric function at the reference angle. And step 4, use the table or figure from the previous video and the quadrant of the original angle to determine the appropriate sign for the function. So let's do an example. Evaluate cosine of 210 degrees using reference angles. Now, the 4 steps that we went over are the following. Step 1, we're going to draw this out. 210 degrees is somewhere in quadrant 3. So that's what our theta is, that's 210. Step 2, the reference angle, theta prime. Well, the reference angle is going to be just this right here. That's going to be our theta prime. And we know theta prime, if it's in quadrant 3, it's going to be 210 degrees minus 180, which is 30 degrees. And so a quick recap, to find what this distance is, or this angle, we would take the full thing minus what we know right here, which is 180, and that leaves this little piece, which is 30 degrees. So now we know our reference angle. Step 3, we know that cosine of 30 degrees, our reference angle, is the square root of 3 over 2. And we've covered that in the previous sections. Step 4, since 210 degrees is in quadrant 3, then we know, and we can kind of think about all students take calculus. In quadrant 3, tangent is positive, so sine and cosine will be negative. So cosine of theta is negative. So therefore, cosine of 210 degrees is equal to this value, square root of 3 over 2, but negative. Now let's do another example. And let's say we want to evaluate tangent of 7 pi over 4. So again, we draw a circle, and 7 pi over 4, that's in quadrant 4. It's bigger than 3 pi over 2, but less than 2 pi. So our angle is theta, looks something like that. So that's really our step 1, just drawing this out. Our reference angle is going to be this angle right here, theta prime. So step 2, the reference angle, theta prime, and how do we get that? We see that theta plus our reference angle theta prime is one complete circle, or 2 pi is theta plus theta prime. And so if we subtract theta from both sides, we get theta prime is 2 pi minus theta, which is 2 pi minus 7 pi over 4. Now we can rewrite 2 pi in terms of having a denominator of 4. So 2 is the same as 8 over 4. So 2 pi is 8 pi over 4, minus 7 pi over 4, and that gives us our reference angle, which is pi over 4. Now, step 3, we compute tangent at that reference angle, tangent of pi over 4, and that is 1. And so, since we know that 7 pi over 4 is in quadrant 4, so we're down here in quadrant 4, cosine's positive, that means the other two values, sine is negative and tangent is negative. So tangent's negative in quadrant 4. Therefore, our value for tangent of 7 pi over 4 is going to be what we have for the reference angle, but negative. So it's negative 1. This is an example where we want to calculate sine of theta and cosine of theta if our value for theta is 20 pi over 3. So our angle, 20 pi over 3, well, where is that? Just looking at this value of 20 pi over 3, it's about like 6.7 pi. So we're bigger than one full rotation of a circle. In fact, we're several rotations of circles. So let's actually subtract rotations of circles, or 2 pi, from this to get our what this looks like. So we're going to have 20 pi over 3, and we're going to subtract 2 pi. To have a common denominator of 3, 2 pi can be rewritten as 6 pi over 3, and that gives us 14 pi over 3. Now, 14 over 3 is still bigger than 2, so we're still bigger than 2 pi. What we're going to do is we're going to continue to subtract multiples of 2 pi until we get something between 0 and 2 pi. So the first time we subtracted 2 pi, now we'll try and take 20 pi over 3 and we're going to subtract 4 pi. So that's 2 rotations. 20 over 3 pi minus 4, if we have the denominator 3, would be 12. 4 divided by 3 is 12. So 12 pi over 3. And so 20 pi over 3 minus 12 pi over 3 gives us 8 pi over 3. That's still bigger than 2 pi. 8 over 3 is bigger than 2. So we're going to try another one. Now we'll go around and subtract 6 pi. So that's going around the circle 3 times. 2 pi, 2 pi, and 2 pi. 20 pi over 3 minus 6 gives us 18 pi over 3, and we're left with 2 pi over 3. So we finally have this value of 2 pi over 3. So we have that if we went around 1 time, so 2 pi, 4 pi, 6 pi, and then we had an extra 2 pi over 3, which would take us somewhere into the second quadrant. 2 pi over 3 takes us into that second quadrant. And that's what our angle theta looks like. And so in fact, what we did is we actually showed that 20 pi over 3 is coterminal. The coterminal angle with 2 pi over 3. So our problem is the same as if our angle theta was just 2 pi over 3. And so we're going to treat it like that. So we drew this out. The next step is to find the reference angle, theta prime. theta prime. So our theta prime is going to be pi minus 2 pi over 3. So we get 3 pi over 3 minus 2 pi over 3, or just pi over 3. That's our reference angle theta prime. And then we know that step 3, that was step 2. Step 3 is sine of pi over 3, which is equal to square root of 3 over 2. And if we're to find cosine as well, cosine of pi over 3 is 1/2. Now we're in, for step 4, we look at our quadrant, right? All students take calculus. In quadrant 2, sine is positive and cosine and tangent, the other ones, are negative. So if sine is positive, we get that sine of our angle, 2 pi over 3, is positive square root of 3 over 2. But not only that, this is the same, since we know sine of 2 pi over 3 and 20 pi over 3, this is going to be the same as sine of 20 pi over 3. Similarly, with cosine, we get cosine of 20 pi over 3 is the same as cosine of 2 pi over 3. And since cosine is negative, we're going to take this 1/2 and put the negative in front. And so it's a little bit harder example, but this is how we can do this.